What is this? What is this? Question? You had a doubt? Okay. So what is this notation? S means symmetric, right? N means it's an n cross n matrix. Plus means positive definite. Plus means positive semi-definite. Okay. Fine. So it's a symmetric positive definite n cross n matrix. Okay. So what is operator norm of A? Can you guess? Of course, we wouldn't know the answer clearly, but can you guess? We will see why this is true when we study optimization, because it's an optimization problem that you have to solve. Let's see why, but can you guess? Huh? Can somebody guess? A is symmetric. So the moment you say symmetric, what is the first thing that it will come? What is it that it will come to your mind? Huh? If I say symmetric matrix, what is the first thing that you will? Huh? Yes, somebody. What is the first thing that comes to your mind when I say that the matrix is symmetric? Huh? Huh? That is symmetric definition. Okay, what else? Consequences of that. That's a property. Okay, fine. What else? Okay, first thing is definition. Fine, good. The second thing is slightly more complicated. Determinant of A is okay. Determinant of A Hermitian. Well, that is because A equal to A Hermitian. There is nothing. First implies second. Okay, let's take it as one. Then yes. Huh? Real? Okay, good. Real eigenvalues. What else? Huh? Diagonalizable, meaning what? It has eigenvalue decomposition. With the, what can you say about the eigenvalues? Of course, you said it's real. That's fine. Anything else you can say? Huh? Greater than zero. Good, right? So it's eigenvalue decomposable. All the eigenvalues are non-negative, right? So it's in fact greater than zero, strictly positive, right? So now with this, can you guess what this operator should be? See, I'm looking at unit vectors and operating it, and I'm looking at the size of that operate, whatever, AX, right? In which direction, if I put X, AX will have the largest length. Huh? Which direction? Huh? You take any X, right? I can write it as linear combinations of bases. So if I have eigenvalue decomposition, all the columns are orthonormal. That forms a basis. So I can write it as linear combinations of all the. Okay, so let's look at that. I think we don't need we don't need optimization to prove this. Let's see. Okay, so question, right? Let X belong to Cn. What is X? X is, let's say alpha I, let's say Vi. Okay. So what are Vi? So this implies A is V lambda V Hermitian. Okay. So lambda is the diagonal. I'll write it as U lambda U Hermitian or V lambda V Hermitian. So the ith column of V is Vi. Okay. They are orthonormal vectors. So is this fine? Vi forms a basis and I can write. So what is Ax now? Ax is alpha I AVI. What is AVI? Vi is an eigenvector of A, right? What is AVI? Huh? Alpha I lambda I Vi. Okay. I'm looking at the norm of this, right? So what is the norm of Ax2? So this is what do I get? I get norm of sum over all I equal to 1 to n. So this leads to some other thing that we need, right? What can you say about, maybe I'll take square also. Okay, what's that? Then we can take square root later. So what is norm squared of, see, this is some constant, right? Let me call this as some beta I. So it's beta I, vi, summation or all I, I'm looking at the length of that. So what will be the length of these two? Can somebody guess? Think of it as in 2-dimension and you have, yes, it's orthonormal. Let's say AV1 plus BV2 norm squared. It will be equal to V1, V2 are orthonormal. Huh? Well, I have multiplied by AV1 plus BV2, right? Then, huh? Okay, let's check, right? Let's check for 2, okay? So this is an aside. Well, not really an aside. Let's check. So you take norm of AV1 plus BV2. Okay. V1 Hamish V2 is, oh, well, let's look at real. Okay. So to make our life easy, it is 0. Otherwise, you have to keep track of all, conjugation and all that. Is this fine? So I want to, what is norm squared? You agree with this? I can write it as inner product of this with respect to itself. Now, I can apply linearity. AV1 I'll do, okay, maybe I'll do every step. Okay, this is the first step. Then I'll pull A out. Then I'll pull B out. Then I'll pull A out here. Then I'll pull B out. Okay, this is A squared. What is V1 inner product with V1? Huh? Norm of V1. If it is orthonormal, let's also assume this V1 squared equal to V2 squared equal to 1. It means they are orthonormal. This will be 1, right? What can you say about V1 inner product with V2? 0. B, this will also be 0, right? B squared times norm of V2 squared, which is 1. So we'll get A squared plus B squared, right? So based on this, what can you say here? Suppose I have 3 vectors which are orthonormal. Same argument, what do you get? Same argument, what do you get? Sum of the, right? So this will be alpha I squared, lambda I squared, right? Fine. Now I have to divide. So remember this alpha I squared over lambda I squared. So what can you say about this? What is norm of x squared? This is summation I equal to 1 to n alpha I squared lambda I squared divided by x is what? Alpha I vi, right? Again, I can apply the same thing here, right? Alpha I vi norm squared is summation alpha I squared, right? Is that fine, everyone? See, remember everything is positive now, right? The alpha I squared, lambda I squared and all that, right? So what will be the x? So now the question is, what is my choice here? So I should find x, right? That means I should find alpha i's. Now, what is the problem? The problem would be the following, right? Maximize over all alpha 1 through alpha n summation I equal to 1 to n alpha I squared divided by summation alpha I squared times lambda I squared, right? Okay, let me look at some geometry here. Okay, so let's look at this, right? Let's look at this. Let me call this vector as beta I, this thing as beta I. Now, what do we have here? So we have beta 1, beta 2, beta n times lambda 1 squared, lambda 2 squared, and so on, lambda n squared. You agree? Beta 1, lambda 1 squared plus beta 2, lambda 2. That's what we have. When do you get this as maximum? You have one vector and you have the other vector and you are projecting. When do you get the maximum? When it is in the direction, right? and it has to have unit norm. So what should be alpha I now? See, alpha I squared over this should be aligned along the direction of this thing, right? And also, okay, so now, what is the maximum lambda I? Okay, so let me, I think you don't even need this. This is good. It's an important information, but see, if I choose alpha 1 equal to 1 and all others 0, see, definitely this is less than lambda 1 squared, right? You can never be larger than lambda 1 squared because I'm multiplying each lambda I squared by a number less than 1, right? I'm adding them. You better, so if you have 3 shares, right, you know that one is going to go up by 100 times, the other one is going to go up by 20 times, and the other one is by 5 times. Where will you put your money? Are you going to put money in 3 places? No, right? 100. I'll put all my money, all by bet there, right? So that means alpha 1 equal to 1 will give me, and alpha 2 equal to 0, alpha 3 equal to 0 will give me lambda 1 squared, which is the maximum, right? Choose alpha 1 equal to 1. What does that imply? X equal to V1. That means I should choose X to be V1. So what does that mean? If I choose X equal to V1, I think I'll stop here. If I choose X equal to V1, AX will be what? Lambda 1 V1, right? So what will be the norm of this divided by this? Will be the max eigenvalue, right? You have to take the square root. Remember, I'm taking square here, norm squared. So I'll get the maximum eigenvalue, right? So the operator norm is nothing but lambda max. Well, this is true, okay? I think I'll stop here. A gentle reminder on the next quiz, okay? Those who are online, I don't know, wherever you are, it's your responsibility to come on campus and then write the exam, okay? Okay, so any questions?